So at this point in the course, I'd like to take a moment and talk about procedural workflows and non-procedural workflows and how they relate to tool building. So in Houdini, I think there's a tendency and a temptation to try and make everything procedural, and that you just want to try and automate every last thing in your setup so that you just give it some geometry and it just does everything all by itself with little or no interaction from the user. And in some situations, I think this sort of approach is totally appropriate. However, I would like to suggest that obsessing over this kind of mentality and trying to make every last thing in your setup completely procedural so that users don't have to interact with it at all is, I think that under certain situations that can get you into trouble. And we're going to look at a few examples today of some problems that might be difficult to solve procedurally that, if we create a non-procedural setup, might be a little bit easier to solve. So let's just take a look at this setup that we've been working with. Now, if you remember this setup, it's just a grid. There's some velocity on the grid that causes particles to shoot up and fall down. And if you look, there it is. So what if we wanted different particles on different parts of the grid to shoot up different amounts and maybe shoot out in different directions, not just straight up? Because this kind of thing is kind of boring. So let's do something a little bit more interesting. So the way that I could do this, if I wanted to make it really procedural, is I could just add some noise to that grid. So if we select this guy, and if you remember, this velocity that we're adding here is what causes the particles to shoot off in different directions at different velocities. So what I could do is I could just say noise, open parenthesis, $tx, $ty, $tz, close parenthesis. And if you remember back to your basic Houdini days, this just creates a noise field, and we're giving it the point positions of each point as the sample value for the noise field. So if I hit enter, and now if we play, they kind of go in different directions. I can just copy and paste this expression. So this is in the y component of the velocity. And I'll just give it a wildly different position so that we get something different. So I can do that. And then this is the z component, so I'll just subtract 5,000. So now it's just different sample locations inside the noise field. And if I hit play, they kind of all go in different directions. Some of them go up, some of them go down. You'll notice that they don't really go up very much. And that's because our y velocity is now between -1 and 1 instead of just 5. So I'll just multiply this by 10. And there we go. So let's take a look at what we have to do in order to control this kind of setup. So the first thing that we might want to do is, well, the first thing that we might notice is that when we play it, the particles kind of, the pattern and shape that they make is very random looking. They kind of all just shoot off on their own. And there is a little bit of a pattern to it, but it's not as much as we might like. So we can do that by controlling the frequency of the noise. And the frequency of the noise is simply a value that we can multiply against each component of the position in the noise function. So we could just do something like this times 0.5 times 0.5 times 0.5, and then go to even here and say times 0.5 times 0.5, and again in z times 0.5, and then go to the next one, times 0.5 times 0.5, and I'm deliberately taking a long time to do this to show you how annoying it is potentially. Okay, so all I did was I went to each channel, or each component of the velocity vector, and I multiplied by 0.5 against each of the components going into the noise function. So that's all it was. And what that'll do is it'll give me half the frequency, which means that the noise pattern will appear to be twice as big as it actually is. So now if I hit play, we get a much more distinctive looking pattern. Now, you may have noticed that it took me a really long time to do that, and that kind of sucks because I don't want to have to, every time I want to change that, I don't want to have to go through and put 5.4.4.4. So the way that we can control that is by using what's called a spare parameter. So the way that you add a spare parameter to a node is you go to the node options menu, which is this little gear looking icon right here. It's in the top right of the parameter pane. If you just click that and pull it down, there's this edit parameter interface. It's the first one in the menu. So if you click on that, it brings up this dialog where we can add parameters. Now the way that we add parameters to the node is we have a whole bunch of types of parameters over here. So here's a float, here's a couple of different types of vectors. You can get a file or specifically a geometry file. And we'll be going over all of these, or a lot of them, in a lot more detail later, because this is the same dialog that we'll be using for our more advanced tool building videos. But for now, I just want one number that I can change to control the overall frequency of the noise in all three channels. So what we can do to do that is we just want this float here. So if we click on that and drag it over into the existing parameters, so right there, I like to put them at the top because it makes them really easy to find. And then you'll notice that it says label parm, and actually, and I'll just make this window a little bit smaller. You can see that it added a single float value. The label is label, and you can see that here. And then the name, if I hover over it, you get the tooltip, the name is parm, which you can see here. So it's good to change these because otherwise no one will ever know what you're talking about. So it's the same thing as naming nodes. You have to make sure to name your parameters as well. So what I'm going to do is I'm going to call this FREQ, or freak, for frequency, not the other thing. And then for label, I can either just delete it, and then now if I hit apply, you can see that it just changed the label to be the same thing as the name because I didn't give it a label. Or I can call it something like frequency, so it'll look nice and pretty. Okay, so now that we have this channel called frequency, we can just hit accept here to get rid of the menu. Now we need to actually use it in this node. So the way that we do that is with a channel reference, the way we would with any other channel. So if we go back to the particle tab where our velocity is, this number here is our actual frequency, so we just need to make that reference this channel. So if I grab that, we can just type ch, and we don't need any dots or anything because we're referencing a channel that's on the same node. And if you remember, I called it FREQ for freak or frequency. Close quotes, close parentheses. And now I'm just going to copy it, Control C, and paste, Control V, and paste. So in the end, you have your noise function where each component of the sample position is being multiplied by this channel frequency. Now if I just hit enter, we can go and do the same thing to the y component. I'm just going to get rid of times 0.5 and add in times chfreak. There we go. Go to the next one. Times chfreak, times chfreak, and times chfreak. Okay, I'm just gonna get that back. So now our frequency should be 0, so if we hit play, nothing happens. Because all of our velocities are set to 0, and that's because all of our frequencies are set to 0. So now I can just change this frequency, and I get my noise back. So I can make it something like 0.4 now, hit play, and we get our nice pattern. So this type of thing makes very procedural setups really easy to control. And there are certainly a few other things that we could do to make this setup easy to control, but I'd like to move on. So if someone wants a particular part of this grid to explode, using this noise frequency, it might be very difficult to do, because if you make this part of the grid explode, it might make this part of the grid not look the way that you want. And so you have to search around and find a position in the noise function that does exactly what you want if you need to be that specific. And for some effects, you do need to be that specific. So for some effects, simply having this noise function is not good enough. And oftentimes people can make this work. They can make sure that the right parts of the grid are going in the right directions at the right time just by playing with sample positions and noise fields. And for some situations, this is fine. Usually if you don't particularly care where things are going, but if we want to get more specific, then it might be better to give a little bit more control over what's going on. And we can do that using a slightly non-procedural part of the setup that we use in our procedural setup. What do I mean by this? Well, what if we just grab these and move them over a little bit? And then we create an add SOP. So I'll just hit tab over here and add. And then I'll just click on this guy to add a point. Now if I display this, you can see if I display points and point numbers, you can see that there's a point there. Which I could just move around like this, but I'd like to have a little bit more control. The handles for the add SOP are not very handy. So let's just add a transform SOP instead. So I set it all back to 0. So notice that the position of the point is 0. I just hit Control Z there to do that. So instead of using the add SOPs handle, I'm just gonna right click on that guy, type transform, and we can just put that down and maybe display it. And now if I put my cursor in the viewport and hit the T key, because rotation doesn't really mean anything, now when I move this point around, I have a very nice handle for doing so. Which you may recognize this as being part of the homework for last week. Okay, so now how do we actually use this? Well, we're going to have this point that we're going to use in our setup. So anytime you have something that you're planning on referencing, it's best not to reference these nodes that do things. And the reason for that is we may not actually be done with this point. We might want to add attributes to it, for example, which we're going to do later. So in that case, if I just move these up a little bit, it's better to add a null at the end, and we reference that null. And then if we need to add any other nodes to this chain, we can just put them above the null, and we know that we're going to pick them up everywhere in our setup that's referencing it. So let's go ahead and do that. So right click here, we can add a null. And I'll just call it control point out. And again, notice that I'm capitalizing it, and that'll make it really easy to find later. And lastly, remember it's a null SOP, so we need to actually name it. Or we need to actually make it a particular color. So if we select it and hit the C key, we can make it blue, so it'll follow our convention. Alright, so the idea here is I want to have this point, and then within a certain radius, I want to make the particles shoot out from this point. So how would we do that? Well, I already have a node here that makes the particles shoot out. So what if we just make this node only activate within a certain radius of this point? So if we just move this up, make our box a little bit bigger, we'll just need to add one node. And that is our attrib transfer node. So if we hit tab and type attrib transfer, put it down, we can just put it in here, hook it up, and we'll transfer from our point, from our control point. Pull it down. Okay, now unfortunately at this point we don't actually have any attributes to transfer, so we'll need to do that. So what we can do here is just say attrib create and put it down. And then we'll name it something meaningful like control field. And then what it's going to do is it's going to transfer this attribute to the grid within a certain radius. But everywhere else, it's just going to set it to 0. So what we want to do is we want to set this guy to 1 so that it always transfers in the value 1. So we'll just set this guy to 1 under value. And now we don't actually see anything, and that's because we just created an arbitrary attribute. So we can visualize that using color. So if I just off to the side here, I create another point swap. I'll just plug it in here and display it. Change keep color to add color, and then Control Shift click to get rid of all the expressions in the color field. And then I think we'll just use the green color. So let's set red to 0, leave green at 1, set blue to 0. So now it's made the entire grid green. And now we want to visualize our control field attribute. So let's just say $control field here. Okay, so our control point around, we can see what it's doing, and it is what we want. It's just a really big radius. So if we go back to our attrib transfer and we go to conditions, we can just turn the distance threshold down. Like that. Now the reason why it wasn't displaying the color before was because I clicked on this attrib transfer, so that was selected. So it was actually trying to display the wrong thing. If you like that in your network editor, you should see your color appear. And now I can control how big that is. I'm going to put it at about 5. I'll even just make it exactly 5, just because I'm OCD that way. Okay, so now I have my X-form. I can move it around, put it down here. So now we can just make this entire part explode. But the problem is we haven't actually hooked this up yet. So if we watch, I'm just going to turn off the point display and point number display so that we get this off. It's just this button and this button. Make sure that they're unchecked. What happens if we go to our particles and launch them? Well, they still do the same thing. And that's because we haven't actually told it to change the velocities anywhere on the grid. So we have an attribute which we can use to control those velocities, but we haven't actually made it control the velocities yet. So let's do that. Okay, so all we're going to need to do is scale our velocity vector by this control field attribute. So if I just wire our point swap here into the attrib transfer so that it can pick up that attribute that's being transferred. And now all we have to do is just multiply our noise by $control field. And then again, multiply by $control field. And then again, multiply by $control field. So all 3 components need to be multiplied by that. So now, if I hit play, it only explodes where it's close to that control point. So the last thing I'd kind of like to do to this before we move on is I'd like to make sure that the particles are only there if they are inside our control field. So I don't want to have any of these that just fall straight down. I only want to have these nice explodey ones. So in order to do that, we'll just use a delete node. Delete. And I'll just put it down there. Let's just move up the point swap and put it after the point swap. We're going to be operating on points, so change the entity from point primitives to points. And now the next thing we need to do is we can't do this by just giving it a pattern, because we would need to return a bunch of numbers. So what we can do is we can change delete by pattern to delete by expression. And filter expression here, we just need to give it some expression that tells it where to delete. In that case, we want it to delete wherever the control field is 0. So we do $control field $=0, and that deletes everywhere where there is no control field. If we play, you can see that it's doing a similar thing. So now I can just move around this explosion point. It allows me to very visually and creatively control what's going on in the setup. So the great thing about this is that as someone picking up this setup, the only part of the setup that I'm really going to need to interact with is this part, right here. So in the previous example where we were using a noise field to control the setup, there could be a whole bunch of noise fields, and I might have to, as someone picking up the setup, I might have to understand how all those noise fields work together to create the effect that you have already created. With this paradigm, if I'm someone picking up your setup, all you have to tell me is, well, when you're trying to control where the explosions are, you just add points to this part of the setup. Suddenly it's very simple and very clear to understand how to control the setup. I don't have to go through and understand a bunch of complex math to understand how you arrived at the result that you did. With this, I can see, oh, you got your result because you put the control point, here, or maybe here. So this is kind of a powerful idea, because this makes using your setups very simple. And in fact, someone using your setup maybe doesn't even need to understand anything other than this part of it. So you could have something very, very complicated going on down here that's controlling all of the look of your noise and the look of the explosion. And for someone picking up your setup, you don't necessarily even need to understand all of that. You can still control the setup by just controlling these.